Aphorism 13 of Book 2 of the New Organon. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The New Organon by Francis Bacon. Translated by James Spedding, Robert Leslie Ellis, and Douglas Denon Heath. Aphorism 13 of Book 2. 13. Thirdly, we must make a presentation to the understanding of instances in which the nature under inquiry is found in different degrees, more or less, which must be done by making a comparison either of its increase and decrease in the same subject, or of its amount in different subjects, as compared one with another. For since the form of a thing is the very thing itself, and the thing differs from the form no otherwise than as the apparent differs from the real, or the external from the internal, or the thing in reference to man from the thing in reference to the universe, it necessarily follows that no nature can be taken as the true form, unless it always decrease when the nature in question decreases, and in like manner always increase when the nature in question increases. This table therefore I call the table of degrees, or the table of comparison. Table of degrees or comparison in heat. I will therefore first speak of those substances which contain no degree at all of heat perceptible to the touch, but seem to have a certain potential heat only, or disposition and preparation for hotness. After that I shall proceed to substances which are hot actually, and to the touch, and to their intensities and degrees. 1. In solid and tangible bodies we find nothing which is in its nature originally hot, for no stone, metal, sulfur, fossil, wood, water, or carcass of animal is found to be hot. And the hot water in baths seem to be heated by external causes, whether it be by flame or subterraneous fire, such as is thrown up from Etna and many other mountains, or by the conflict of bodies, as heat is caused in the dissolution of iron and tin. There is therefore no degree of heat palpable to the touch in animate substances, but they differ in degree of cold, wood not being equally cold with metal, but this belongs to the table of degrees in cold. 2. As far, however, as potential heat and aptitude for flame is concerned, there are many inanimate substances found strongly disposed thereto, as sulfur, naphtha, rock oil. 3. Substances once hot, as horse dung from animal heat, and lime, or perhaps ashes and soot from fire, retain some latent remains of their former heat. Hence, certain distillations and resolutions of bodies are made by burying them in horse dung, and heat is excited in lime by sprinkling it with water, as already mentioned. 4. In the vegetable creation we find no plant or part of plant, as gum or pitch, which is warm to the human touch. But yet, as stated above, green herbs gain warmth by being shut up. And to the internal touch, as the palate or stomach, and even to external parts, after a little time, as in plasters and ointments, some vegetables are perceptibly warm, and others cold. 5. In the parts of animals after death or separation from the body, we find nothing warm to the human touch. Not even horse dung, unless enclosed and buried, retains its heat. But yet all dung seems to have a potential heat, as is seen in the fattening of the land. In like manner carcasses of animals have some such latent and potential heat, insomuch that in burying grounds, where burials take place daily, the earth collects a certain hidden heat which consumes a body newly laid in it much more speedily than pure earth. We are told too that in the East there is discovered a fine soft texture made from the down of birds, which by an innate force dissolves and melts butter when lightly wrapped in it. 6. Substances which fatten the soil, as dung of all kinds, chalk, sea sand, salt, and the like, have some disposition to heat. 7. All putrefaction contains in itself certain elements of a slight heat, though not so much as to be perceived by the touch. For not even those substances which on putrefaction turn into animalcula, as flesh, cheese, etc., feel warm to the touch. No more does rotten wood, which shines in the dark. Heat, however, in putrid substances sometimes betrays itself by foul and powerful odors. 8. The first degree of heat, therefore, among those substances which feel hot to the touch, seems to be the heat of animals, which has a pretty great extent in its degrees, for the lowest, as in insects, is hardly perceptible to the touch, but the highest scarcely equals the sun's heat in the hottest countries and seasons, nor is it too great to be borne by the hand. It is said, however, of Constantius and some others of a very dry constitution and habit of body, that in violent fevers they become so hot as somewhat to burn the hand that touched them. 9. Animals increase in heat by motion and exercise, wine, feasting, Venus, burning fevers, and pain. 10. When attacked by intermittent fevers, animals are at first seized with cold and shivering, but soon after they become exceedingly hot, which is their condition from the first in burning and pestilential fevers. 11. Let further inquiry be made into the different degrees of heat in different animals, as in fishes, quadrupeds, serpents, birds, and also according to their species, as in the lion, the kite, the man. For in common opinion, fish are the least hot internally, and birds the hottest, especially doves, hawks, and sparrows. 12. Let further inquiry be made into the different degrees of heat in the different parts and limbs of the same animal. For milk, blood, seed, eggs are found to be hot only in moderate degree, and less hot than the outer flesh of the animal when in motion or agitated. But what the degree of heat is in the brain, stomach, heart, etc., has not yet been in like manner inquired. 13. All animals in winter and cold weather are cold externally, but internally they are thought to be even hotter. 14. The heat of the heavenly bodies, even in the hottest countries and at the hottest times of the year and day, is never sufficiently strong to set on fire or burn the driest wood or straw, or even tinder, unless strengthened by burning glass or mirrors. It is, however, able to extract vapor from moist substances. 15. By the tradition of astronomers, some stars are hotter than others. Of planets, Mars is accounted the hottest after the sun, then comes Jupiter, and then Venus. Others again are set down as cold, the moon for instance, and above all Saturn. Of the fixed stars, Sirius is said to be the hottest, then Coriolanus, or Regulus, then Canicula, and so on. 16. The sun gives greater heat the nearer he approaches to the perpendicular or zenith, and this is probably true of the other planets also, according to the proportion of their heat. Jupiter, for instance, is hotter, probably, to us when under Cancer or Leo than under Capricorn or Aquarius. 17. We must also believe that the sun and other planets give more heat in perigee, for their proximity to the earth, than they do in apogee. But if it happens that in some region the sun is at the same time in perigee and near the perpendicular, his heat must of necessity be greater than in a region where he is also in perigee, but shining more obliquely. And therefore the altitude of the planets and their exaltation in different regions ought to be noted, with respect to perpendicularity or obliquity. 18. The sun and other planets are supposed to give greater heat when nearer to the larger fixed stars. Thus, when the sun is in Leo, he is nearer Coriolanus, Cauda Leonis, Spica Virginis, Sirius, and Canicula, than when he is in Cancer, in which sign, however, he is nearer to the perpendicular. And it must be supposed that those parts of the heavens shed the greatest heat, though it is not at all perceptible to the touch, which are the most adorned with stars, especially of a larger size. 19. Altogether the heat of the heavenly bodies is increased in three ways. First, by perpendicularity. Secondly, by proximity or perigee. Thirdly, by the conjunction or combination of stars. 20. The heat of animals and of the rays of the heavenly bodies also, as they reach us, is found to differ by a wide interval from flame, though of the mildest form, and from all ignited bodies, and from liquids also, and air itself when highly heated by fire. For the flame of spirit of wine, though scattered and not condensed, is yet sufficient to set paper, straw, or linen on fire, which the heat of animals will never do, or of the sun without burning glass or mirror. 21. There are, however, many degrees of strength and weakness in the heat of flame and ignited bodies, but as they have never been diligently inquired into, we must pass them lightly over. It appears, however, that of all flame that of spirit of wine is the softest, unless perhaps ignis faucis be softer, and the flames or sparklings arising from the sweat of animals. Next to this, as I suppose, comes flame from light and porous vegetable matter, as straw, reeds, and dried leaves, from which the flame from hairs or feathers does not much differ. Next, perhaps, comes flame from wood, especially such as contains but little rosin or pitch. With this distinction, however, that the flame from small pieces of wood, such as are commonly tied up in faggots, is milder than the flame from trunks and roots of trees. And this you may try any day in furnaces for smelting iron, in which a fire made from faggots and boughs of trees is of no great use. After this, I think, comes flame from oil, tallow, wax, and such like fat and oily substances, which have no great acrimony. But the most violent heat is found in pitch and rosin, and yet more in sulfur, camphor, naphtha, rock oil, and salts, after the crude matter is discharged, and in their compounds, as gunpowder, Greek fire, commonly called wildfire, and its different kinds, which have so stubborn a heat that they are not easily extinguished by water. 22. I think also that the flame which results from some imperfect metals is very strong and eager, but on these points let further inquiry be made. 23. The flame of powerful lightning seems to exceed in strength all the former, for it has even been known to melt wrought iron into drops, which those other flames cannot do. 24. In ignited bodies, too, there are different degrees of heat, though these again have not yet been diligently examined. The weakest heat of all, I think, is that from tinder, such as we use to kindle flame with, and in like manner that of touchwood or tow, which is used in firing cannon. After this comes ignited wood or coal, and also bricks, and the like heated to ignition. But of all ignited substances, the hottest, as I take it, are ignited metals, as iron, copper, etc., but these require further investigation. 25. Some ignited bodies are found to be much hotter than some flames. Ignited iron, for instance, is much hotter and more consuming than flame of spirit of wine. 26. Of substances also which are not ignited but only heated by fire, as boiling water and air confined in furnaces, some are found to exceed in heat many flames and ignited substances. 27. Motion increases heat, as you may see in bellows and by blowing, insomuch that the harder metals are not dissolved or melted by the dead or quiet fire, till it be made intense by blowing. 28. Let trial be made with burning glasses, which, as I remember, act thus. If you place a burning glass at the distance of, say, a span from a combustible body, it will not burn or consume it so easily as if it were first placed at the distance of, say, half a span, and then moved gradually and slowly to the distance of the whole span. And yet the cone and union of rays are the same, but the motion itself increases the operation of the heat. 29. Fires which break out during a strong wind are thought to make greater progress against than with it, because the flame recoils more violently when the wind gives way than it advances while the wind is driving it on. 30. Flame does not burst out, nor is it generated, unless some hollow space be allowed it to move and play in, except the explosive flame of gunpowder and the like, where compression and imprisonment increase its fury. 31. An anvil grows very hot under the hammer, insomuch that if it were made of a thin plate it might, I suppose, with strong and continuous blows of the hammer, grow red like ignited iron. But let this be tried by experiment. 32. But in ignited substances which are porous, so as to give the fire room to move, if this motion be checked by strong compression, the fire is immediately extinguished. For instance, when tinder, or the burning wick of a candle or lamp, or even live charcoal or coal, is pressed down with an extinguisher, or with the foot, or any similar instrument, the operation of the fire instantly ceases. 33. Approximation to a hot body increases heat in proportion to the degree of approximation, and this is the case also with light, for the nearer an object is brought to the light, the more visible it becomes. 34. The union of different heats increases heat, unless the hot substances be mixed together. For a larger fire and a smaller fire in the same room increase one another's heat, but warm water plunged into boiling water cools it. 35. The continued application of a hot body increases heat, because heat, perpetually passing and emanating from it, mingles with the previously existing heat, and so multiplies the heat. For a fire does not warm a room as well in half an hour as it does if continued throughout the whole hour. But this is not the case with light, for a lamp or candle gives no more light after it has been long lighted than it did at the first. 36. Irritation by surrounding cold increases heat, as you can see in fires during a sharp frost. And this, I think, is owing not merely to the confinement and contraction of the heat, which is a kind of union, but also to irritation. Thus, when air or a stick is violently compressed or bent, it recoils not merely to the point it was forced from, but beyond it on the other side. Let trial therefore be carefully made by putting a stick or some such thing into flame, and observing whether it is not burnt more quickly at the sides than in the middle of the flame. 37. There are many degrees of susceptibility of heat, and first of all it is to be observed how slight and faint a heat changes, and somewhat warms even those bodies which are least of all susceptible of heat. Even the heat of the hand communicates some heat to a ball of lead or any metal, if held in it a little while. So readily and so universally is heat transmitted and excited, the body remaining to all appearances unchanged. 38. Of all substances that we are acquainted with, the one which most readily receives and loses heat is air, as is best seen in calendar glasses, air thermoscopes, which are made thus. Take a glass with a hollow belly, a thin and oblong neck. Turn it upside down and lower it, with the mouth downwards and the belly upwards, into another glass vessel containing water, and let the mouth of the inserted vessel touch the bottom of the receiving vessel, and its neck lean slightly against the mouth of the other, so that it can stand. And that this may be done more conveniently, apply a little wax to the mouth of the receiving glass, but not so as to seal its mouth quite up, in order that the motion, of which we are going to speak, and which is very facile and delicate, may not be impeded by want of supply of air. The lowered glass, before being inserted to the other, must be heated before a fire in its upper part, that is, its belly, Now when it is placed in the position I have described, the air which was dilated by the heat will, after a lapse of time sufficient to allow for the extinction of that adventitious heat, withdraw and contract itself to the same extension or dimension as that of the surrounding air at the time of the immersion of the glass, and will draw the water upwards to a corresponding height. To the side of the glass there should be affixed a strip of paper, narrow and oblong, and marked with as many degrees as you choose. You will then see, according as the day is warm or cold, that the air contracts under the action of cold and expands under the action of heat, as will be seen by the water rising when the air contracts and sinking when it dilates. But the air's sense of heat and cold is so subtle and exquisite as far to exceed the perception of the human touch, insomuch that a ray of sunshine, or the heat of the breath, much more the heat of one's hand placed on the top of a glass, will cause the water immediately to sink in a perceptible degree. And yet I think that animal spirits have a sense of heat and cold more exquisite still, were it not that it is impeded and deadened by the grossness of the body. 39. Next to air, I take those bodies to be most sensitive to heat which have been recently changed and compressed by cold, as snow and ice. For they begin to dissolve and melt with any gentle heat. Next to them, perhaps, comes quicksilver. After that follow greasy substances, as oil, butter, and the like. Then comes wood, then water, and lastly stone and metals, which are slow to heat, especially in the inside. These, however, when once they have acquired heat, retain it very long, insomuch that an ignited brick, stone, or piece of iron, when plunged into a basin of water, will remain for a quarter of an hour, or thereabout, so hot that you cannot touch it. 40. The less the mass of a body, the sooner it is heated by the approach of a hot body, which shows that all heat of which we have experience is in some sort opposed to tangible matter. 41. Heat, as far as regards the sense and touch of man, is a thing various and relative, insomuch that tepid water feels hot if the hand be cold, but cold if the hand be hot. End of Aphorism 13 of Book 2. Recorded by Craig Campbell in Appleton, Wisconsin in 2009.